Inevitably, you're going to want to take the variables and data that you've created and write them out into files or into reports of some sort. And string formatting is a major part of this. So let's look at how you do this. Strings, we created a little string in here, have a method on them called format. And it can take an arbitrary number of arguments passed in here. And we'll notice that we have 3 sets of curly brackets inside of this string, and those actually aren't going to print out. Those are indicators of where you want values from the format arguments coming in. So in this first set of curly brackets, the value A is going to be put in there. The second will get B, and the third will get C. So you print out A, B, C here. It's also possible to put inside of these curly brackets a whole lot of things, but one of the things you can do is specify, instead of taking the 0th argument that's passed into format, which was A, I want to take the index 2 argument that's passed in, which is going to be C, and then the index 1, which is B, and the index 0, which is A. So now you'll print out C, B, and A. There's an alternative form that will actually allow you to name the variables that are passed into format. So you'll notice n equal 10, x equal 1.5, and color equal blue are specified over here. And now we can use those names within our curly brackets to indicate which one of those values will be put in place in our format string. It's possible also to mix these together. Not sure that I would recommend this, but here we have color and index values mixed together in our format string. And then this last example shows some of the more advanced features. We have a 0 inside of the first curly brackets, but then we have a colon, and after that you have some format information. What that's saying is, I want to print out whatever is in argument 0, but I'm going to use at least 10 spaces in that area. The column width for that variable is going to be 10 spaces wide. For 1, we've specified that it's going to be 10 spaces wide, and we want it to be printed out as an integer. That's what the D means, and we'll see those format strings in just a minute. And then the third is saying I want it to be at least 10 spaces wide, but it's going to be, this F means a floating point number, and the 0.2 tells you how many decimal places after the floating point number you're going to write out. So you can see that you have a lot of flexibility and can be very specific about how things get written out. This slide gives a little more detail on what's available there. You have this field name that we've specified down here, and then there's a format spec that's afterwards. There's a whole lot of kind of variables that you can put into that. Let's just look at what those might be. There's more than we're going to go over here, but this gives you a bit of a reference. You can specify alignment in the format string. You can specify whether the plus or minus sign on numbers are shown. You can specify the integer type code of how, if you have an integer, whether you want it printed out in binary format or octal or hexadecimal. And then you can specify on floating point numbers whether you're going to use scientific notation, whether you're going to write it out in a general format or in a fixed point format. All sorts of different choices there. These format strings are actually the same if you're familiar with printf and C, and also used in many other languages. So that common knowledge that you've already gained about how to format strings in other languages carries over here. Let's look at some more advanced examples based on this information. We put square brackets here to show the area around the field that got printed out. We're going to print out the X value here with 5 characters, 0 values after the floating point or after the decimal, and make it in floating point format. The next one has 1 value past the decimal point, and the next one has 2 values past the decimal point. So we see 12, 12.3, and 12.35 printed out here. Here we're showing how signs are printed out in the code. So if you put a negative sign in front of your F, that means if a negative sign exists, print it, but if it's positive, just print out the normal positive value. Now, if you put a plus in front of it, then it's going to put the plus sign in front of the number if it's positive and a negative sign in front of it if it's negative. And if you put a space in front of it, then If it's positive, it's just going to print out the space, and if it's negative, it actually puts the negative sign there. That's nice for getting numbers to line up in columns as you want them to be. Here we're showing more about how you can align data. We're setting up the 0th argument here, which is Python, to print out multiple different ways. The left-hand caret here says to left justify this, and we have a 10 there, so we're going to take up 10 spaces in the line when we print it out, and we're going to print it out as a string. The right caret means to right justify this, and then the up caret means to center justify it. If we put a star or some character in front of the justification character, the caret value, then that's going to be the caret that's used to fill. Typically it's just a space if you don't specify it, but here we've specified it with a star and use that to pad around our character. I'll often use this capability when writing out divider lines. Maybe you're doing a checking account and you want to have the deposits and the withdrawals, and you want to have a separator in between them printed out in a fashion like this. And then finally down here we're just showing the different ways of printing out integers. You can take the same integer and print it out as hexadecimal, decimal, octal, and binary. It's worth noting that there's an old style quote-unquote formatting, and that is to take a string. Here's our format string here, again with pretty much the same format codes, but if you follow that with a % and then a tuple, whatever's in this tuple will replace these. So S will be printed out as the string here, X as the floating point, Y as the integer value. And again, we have different floating point conventions that we can use, having spaces in front of values and so on.